Hi guys, welcome to the video on 30, 60, 90 degree triangles. So 30, 60, 90 triangles, we're going to be learning to calculate the measure of the sides of a 30, 60, 90 triangle. We're doing this because 30, 60, 90 triangles are incredibly useful in design and construction and have principles or applications in physics principles. And you'll know you're successful when you can find any of the sides of a 30, 60, 90 triangle given one of three sides. So what is a 30, 60, 90 triangle? A 30, 60, 90 triangle is a scalene right triangle that has a 30 degree angle and a 60 degree angle as its other two angle measurements. 30, 60, 90 triangles have unique relationships between the shortest side and the other two sides. So, what are those unique relationships? The unique relationships that we're going to talk about, it's very important to note that all of these ratios are connected to the shortest leg of the 30, 60, 90 triangle. So, the first ratio is between the shortest leg and the hypotenuse. That ratio is 2, which means you are either multiplying or dividing by 2. The ratio between the shortest leg and the longer leg, so the middle side, is square root of 3, which means that you either multiply or divide that by the square root of 3. So, how it works. If you are calculating the hypotenuse, you multiply the measure of the short leg by 2. So you take the short leg and you multiply it by 2, and that gets you the measure of the hypotenuse. If you have the hypotenuse and you want to calculate the short leg, you're going to divide by 2. Also, if you are calculating the longer leg, this one down here, you multiply the measure of the short leg by the square root of 3. And remember, when you multiply a real number, a rational number by an irrational number, all you do is push them together. You don't actually multiply them because you cannot actually multiply them. If you have the longer leg and you want to calculate the short leg, you are going to divide by the square root of 3. Now, there is no ratio for longer leg to hypotenuse, and that is because you can never go from the longer leg to the hypotenuse. You must always go to the short leg first. Always, always, always. Always have to calculate the short leg. So just keep that in mind as I do my examples here. So, example, what are the measures of sides B and C? The side that I am given is across from the 30 degree angle. So this side here, the 5, is the short side. So I'm going to just write short here. Which means if this is the short side, B is the long side, and that means that C is the hypotenuse. So, when I have the short leg to start, it's relatively simple for me to calculate the hypotenuse and the long side. I'm going to first start by doing the hypotenuse. I can calculate C by taking the measure of the short leg. So SL stands for short leg, multiplied by 2 times 2. So C is going to be equal to 5, the measure of the short leg, times 2, or C is going to be equal to 10. Okay, so I did calculate the measure of C, and that was relatively simple. I'm just going to circle my answer here. For the measure of B, so B is the long leg. Oh, that didn't work out. B is the long leg here. So what I am going to do is B is going to be equal to the measure of the short leg multiplied by the square root of 3. So I know that the short leg is 5. And multiply it by the square root of 3 because that's the special ratio. And the only thing that I can actually do with that is actually say it is 5 times the square root of 3. And that's it. I can't really do anything else with that. So there's my answer. So C is 10 and B is 5 times the square root of 3. Okay, here. What are the measures of sides J and K? first I need to figure out which side it is that I'm actually dealing with. So if I look and draw the arrow here, the 90 degrees and the arrow pointing across the triangle indicates to me that this is the hypotenuse. So if this is the hypotenuse, that's going to make K the shorter leg. And J is going to be the long leg. So, one thing that we have to remember is that we are not allowed to use the hypotenuse to calculate the long leg. The first thing we have to do is calculate the short leg. So I'm going to go from the hypotenuse to the short leg. So in order to calculate K, I'm going to take the hypotenuse and I'm going to divide it by 2. So if I substitute in the value of the hypotenuse of 24 and put it over 2, I get that K is equal to 12. So I've got one of my sides right there. And if I want to then calculate the measure of the long leg, J is the short leg multiplied by the square root of 3. So let's go ahead and substitute the measure of the short leg in. Measure of the short leg is 12. So the measure of the short leg is 12 multiplied by the square root of 3. And honestly, that's all I can do, is then write 12 times the square root of 3. And that is my final answer. So there's the two side lengths. K is 12 and J is 12 times the square root of 3. And for my final example, 12 is across from the 60-degree angle. So if I look at this, that's across from the 60-degree angle, which makes 12 my long side, which means that X is my short side and Y is my hypotenuse. So I'm tempted to go from 12 to the hypotenuse, but I have to remember that I can't do that. I have to go from the long side to the short side. So to calculate the short side, given the long side, the short side, I'm going to write X instead of S. X is going to be equal to the long leg divided by the square root of 3. So I'm going to fill in what I know. So X equals 12 divided by the square root of 3. Now, I'm not allowed to actually divide those. That doesn't equal square root of 4. Instead, I'm left with a radical on the bottom of my fraction. So here, I'm going to have to rationalize this. So let's rationalize it. So I'm just going to write rationalize up here just so everybody has a reminder of what I'm doing. So I'm rationalizing. On the top, I get 12 times the square root of 3. And on the bottom, the square root of 3 times square root of 3 gives me 3. I am then allowed to cancel 12 and 3. 12 and 3 are divisible. 12 divided by 3 is 4 times the square root of 3. So X equals 4 times the square root of 3 as its length. Now that I have this measurement, I can then calculate the measure of the hypotenuse. So Y, I'm going to do my work over here, Y is equal to the short leg, the measure of the short leg, times 2. So I'm going to go ahead and substitute in my value that I got for the short leg of 4 times the square root of 3, and that is multiplied by 2. So when I have a rational number with a radical attached to it, I'm just going to multiply the 4 and the 2, the two rational parts. So 4 and 2 is 8. And the square root of 3 tags along, and that is the measurement of Y, 8 times the square root of 3. And so in summary, guys, 30, 60, 90 triangles are scaling right triangles with unique ratios. We can use those ratios to calculate other missing sides if we know at least one of the sides. And remember, it's 2 is one of the ratios, and the square root of 3 is the other. Your calculations should always include the short leg in some way, meaning you're either going to the short leg or you're coming from the short leg. But remember that you can't skip over from long leg to hypotenuse. That doesn't work. And then, as always, you need to make sure you simplify all your radicals and rationalize any denominators that require it, like in the last example. And that's it for 30, 60, 90 triangles, guys. Thanks for watching, and I'll see you in the next video.